I'm Monica.
I'm Analicia.
I'm Marie.
And this is our
apparatus. Our apparatus exhibits a transfer of kinetic energy to potential energy because when we drop the marble from the tube, from the starting point, as it goes down, it's gaining kinetic energy. So as it goes from kinetic energy to potential energy, the marble is rolling throughout the entire apparatus, and the entire time it has potential energy, because if we took away the machines, then the marble would fall, causing it to have potential energy. Our apparatus exhibits a transfer of potential energy to kinetic energy because once we have the marble in the starting position, it's already at gravitational potential energy, because if you were to release it from your hand, then it'd just fall. So once we drop the marble down the tube, then it starts to gain kinetic energy. And it has kinetic energy through the entire apparatus until it is dropped into the basket.
To find the gravitational potential energy of our starting point, we need to find the height, which is 36.5 inches. And we need to convert it to meters, which is 1.08 meters. And then after that, we need to find the mass of a marble, which is 3.9 grams. But then we need to convert it to kilograms, which is 0.0039 kilograms. And we need to find the energy, which is the mass times gravity times height. And in this case, it would be 1.08 meters times 0.0039 kilograms times 9.8, which is 41.6 joules.
To calculate the speed of which the flag was raised, we first had to find the distance of the zero reference level, which is the ground, to where the flag is. So using a ruler, a standard ruler, we found that it raised about 9.5 inches. We then took this and converted it to meters, which gave us 0.80997861 meters, which was the height from the ground to the flag. We then found the time that it took from the marble to start to end and raise the flag. In our first trial, we got 3.8 seconds. In our second trial, we got 4.2 seconds. In our third trial, we had 3.8 seconds. We then found the average of these three trials and got 3.93 seconds. We then divided the height, which was 0.28099781 meters, by the average time, which was 3.93 seconds, which gave us the speed of 0.071500727 meters per second squared.
We use the equation for the conservation of energy to find the amount of energy lost. And that equation is kinetic energy plus potential energy before is equal to the amount of kinetic energy plus potential energy after. So we start with no kinetic energy because we are holding the ball, so it's not moving at all. And then there is potential energy because as we're holding the ball, if I were to let go of it, then it would drop. So that is potential energy. So after, it only has kinetic energy because it's moving into the basket, but there's no potential energy because the basket is on the floor or the zero reference level. So then we would get the equation 0 plus 0.0415842266 joules is equal to 9.969090225 times 10 to the negative 6 joules plus 0.
Since there is no initial kinetic energy, we can just take the initial potential energy and subtract it by the final kinetic energy. The initial potential energy is 0.041582466 joules, and we minus 9.969090225 times 10 to the negative 6 joules, which gives us an energy of 0.0415729 joules. Our initial was 0.415084266. From these numbers, we can see that there has been a slight loss of energy.
There are several different ways how energy was lost during the apparatus. First, it was when we dropped the marble into the starting point, when it hit the beginning of the spiral, it stopped momentarily, and then it began going. Second is that there's a gap between the end of the spiral and the beginning of the ramp, and so it slowed the marble down because I had a drop from the spiral to the ramp. Third is when the marble hits the bumpers, which makes it slow down. Fourth is when the marble experiences a dip between the cup and the wheel and axle, which makes it slow down and then go. And finally, another encounter is when the marble shoots down the tube and hits the backboard and goes into the basket.
And that's like what I was saying, like back there.
Hey guys, how does this work though?
Well, Marvin, we'll show you. Analicia, good? Good. Monica, good? Good. Good. 1, 2, 3, go!
Well, Mr. Rowney, thanks for watching our video.
See you in class.